alongside the Luray Cavern Spelunker, Tom K.
What's up, bro?
What's going on, man? Welcome back.
Thanks. Yeah, I actually forgot I wasn't here last week.
Yeah.
I just got back from vacation.
How was it?
It was great. Like, I was on the phone with you guys last Monday about the eclipse.
Yeah.
And then just finished up the trip and just got back on Sunday, which was yesterday.
Nice. 10 out of 10. Would do it again?
It was great.
Nice, man.
A lot of science and nature.
Yeah. So do you want to talk about the cavern just to right off the top a little bit before we get into it?
Yeah. It's so it's the biggest cavern system in the United States.
Okay.
It's
Where is it located?
It's in Virginia, Luray, Virginia.
Luray. Okay, so I see.
That's why it's called the Luray Caverns or something like that.
Luray Caverns.
Yeah.
Yeah, nice.
Yeah, so it's formed by when you have acidic water making the caves, and then you get those stalactites and stalagmites growing up, and they look really cool, creepy, and they take millions of years to form, so it was cool.
Awesome. How big was it? Was it like a...
It was really big.
Yeah.
It was like a huge tour that you walk all the way around.
Nice.
It was really cool.
That's awesome. Gotta check that out. But yeah.
Yeah, we got pictures on Facebook and Twitter.
Yes.
If anybody's interested.
Yeah, you put those up. I thought they were phenomenal.
Yeah,
so
pretty
go
cool.
Check those out if you haven't yet. But yeah, it's good to have you back. Kyle Kalita off camera doing the production again this week after a successful fill-in last week. So maybe we'll get that mean mug back on camera one of these days soon. Thank you guys for joining us this week. Of course, this is trèSci Weekly. This is our weekly video podcast where Tom and I discuss trending science news topics. We are on YouTube every Monday night for the live show, which you guys are joining us for right now, unless you're watching this on the replay, right, on our YouTube channel. We would very much appreciate if you would subscribe to the channel if you like this kind of stuff. It helps grow the channel, helps us do bigger and better things with it. You can also follow us on social media, on Facebook.com/trèSciWeekly, on Twitter.com/trèSciWeekly.
Yep.
And you can support us financially, so choose on Patreon.com/trèSciWeekly, where we appreciate any and all patronage. This week we're rolling back into kind of the more normal routine of the show.
Yeah, some more stories besides the solar eclipse.
Yep.
We're moving on.
And we're moving on from the solar eclipse, although I'm sure we'll bring some of that stuff up in future episodes. We will talk a lot about space this week, though.
Just like usual.
Yeah, like usual. There's a lot of cool stuff. But the first thing I want to address, Tom, is, of course, the hurricane that's going on. Hurricane Harvey, which is now actually...
Tropical storm.
It's been declassified, but it was at its highest point a Category 4 hurricane.
Yes, when it was making landfall.
Before we dive in and start chatting a little bit about it, of course, want to send our best regards out to those that are dealing with the hurricane out there. Not just the people that live in that part of Texas, but all the first responders and all the aid that's been sent in for relief.
Yeah. It's definitely a tough situation going on there.
Yeah,
right now.
Absolutely. So our best wishes go out to those that are dealing with it. Yeah. So let's get on into it. I want to talk a little bit about how this hurricane came to be. Right. Like, we're gonna go back before it was it was rampant and doing its thing as a hurricane, because I want to kind of show how quickly things got real serious. Right?
Yeah, because it was in the Gulf of Mexico as its tropical depression and storm, and then while it was still in there before it made landfall, got all the way up to the Category 4. So that was really quick.
Yeah.
It was pretty amazing.
Yeah, so we're going to show a bunch of pictures, a bunch of videos on, basically how the hurricane continued to form over time. And Tom, I hope that you'll be able to lend some expertise and explain some of the things that go into the system here, because I know that you know more than I about it. So here we go. Number 1. Over the weekend, Hurricane Harvey made landfall near Rockport, Texas as a Category 4 hurricane. According to the Saffir-Simpson scale, Category 4 indicates wind speeds of 130 to 156 miles per hour.
Yeah, so when we're categorizing a hurricane, it's only based on wind speed for its categorization.
Correct.
So the max sustained wind speeds was up to a Category 4.
That's right.
Yep.
NASA and NOAA's Geostationary Operational Environmental Satellite, or GOES for short, provides an ongoing chronology of the storm system via satellite imagery. So we'll start with the first image, Kyle, if you don't mind bringing that one up. I'll bring it up on my end over here as well. The quote here from NASA says, at 10:45 a.m. Eastern Time on August 13th, 2017, NOAA's GOES satellite captured a visible image of Atlantic Ocean potential tropical depression 9 approaching the Lesser Antilles, end quote. And so we see here, this is before it reaches kind of the Gulf of Mexico even, just a little swirly dirly.
Yeah, it doesn't look like too much
first,
right there.
Yeah. So, I mean, you can even just tell from what they're classifying it, potential tropical depression 9, right? So nothing over the top threatening.
Yeah, nothing yet.
Just yet.
And that in the bottom left-hand corner is South America, right? Is that what we're looking at there?
I think.
I believe so.
I believe so.
It's got to be.
Yeah, I think we'll see as we continue to zoom forward. Yeah. If we can bring up the second image, Kyle. This next one. So all these images that we're showing you are courtesy of NASA and the NOAA GOES project. This next one reads, NOAA's GOES East satellite provided a visible light image of the remnants of Tropical Storm Harvey, this is now after it's been named, in the Western Caribbean Sea on August 21st at 8:30 a.m. Eastern Time. So now we're moving a little bit forward in time. This was the day of the eclipse, so this was the day that you were down in Tennessee. Kyle and I were doing the show, and now all of a sudden we have a named storm here that is, this is Cuba and the Dominican Republic and the Bahamas and
tip of Florida,
the south tip of Florida.
And this is when it was upgraded to a tropical depression or
tropical storm.
Tropical storm, okay.
Right.
So it's even the next step.
Yeah. So they already kind of knew it was a tropical storm, and now they're classifying this as the remnants of that tropical storm. So they're really expecting it to kind of
dissipate,
fizzle out at this point. But we all know that's not what happens, right? I'm going to bring up first of our videos here, Kyle, if you don't mind. I don't think that there's any sound to any of these, so we won't put the headphones on.
So what are we taking a look at now?
So what we're going to take a look at now is an animation of NOAA's GOES East satellite imagery from August 23rd to August 25th, which shows the redevelopment and movement of Hurricane Harvey in the western Gulf of Mexico. So whenever you're ready to go. Cool.
So now it's in the warm waters of the Gulf of Mexico, and it starts building itself back up. You can see those clouds forming, starting to rotate a little bit.
Yeah.
Yeah, now it's really starting to come together.
The eye form.
It's pretty crazy watching it happen in slow motion.
Yeah.
Well, fast motion, you know.
Yeah, exactly. All right.
So that's impressive. It goes right from a whole bunch of nothing into a hurricane, right across the little Gulf of Mexico.
Yeah.
Pretty crazy.
Yeah. And then the end of the quote there, on August 25th, Harvey was located along the southeastern coast of Texas, right? On August 24th, NOAA's hurricane hunters, part of the Office of Marine and Aviation Operations, released footage of the first flight mission through the eye of the storm. So we have some videos to show you there. These ones definitely we do have some sound, so we'll throw that on.
Thank you. Excuse me.
Yeah. All right.
So this is the hurricane hunters flying into the hurricane to get data.
Correct. Yep. have any other way of really calibrating weather information from inside of a hurricane, right?
Yeah.
So we have that one, and then the same group, the NOAA Hurricane Hunters Twitter account, also uploaded a video, shorter one, of them entering the eye of the storm.
Yeah, this is very cool.
Yeah, so Kyle, let me know when we have that one to bring up as well, if and when. Ready?
So this is one looking into the eye of the storm.
Yeah, so this is, it says, according to the tweet, first passed through the eye of Hurricane Harvey, WP3E Orion, which is the name of the aircraft that they're flying. Credit goes to Lieutenant Kevin Doremus, NOAA, this one. Yeah. It must be a really odd feeling to having passed through something as severe and turbulent as what we just watched in the video prior.
Just being
To being in the eye where things are relatively calmer, and then knowing that the only way out, right,
to go back through.
Yeah, is to go back through.
Or you're just hovering the eye.
Cool.
Yeah, so in the middle of the hurricane, that's the center of the low pressure system, where you have just rising air updrafts through there, and you don't get any cloud coverage in the middle, so that's just the eye of the storm.
Right.
Pretty cool.
So that was on the 24th of August. Moving forward in time, we have another image to bring up. So that would be this guy here. And we can see just how wide the eye of the storm became, which caught me off guard.
Yeah, it became super organized, and I saw a whole bunch of tweets by weather people saying it's like one of the most well-structured hurricanes that they've ever seen at, like, in this image where it's fully formed.
Yeah, it's really impressive, actually. I mean,
it came out of like nowhere as just that little tropical storm, and then it became this massively well-defined hurricane in such a short time.
Yeah, if you can put destruction aside,
Just
and just
taking out what happened,
marvel at the system itself, it is actually quite beautiful in a sense. The quote here from NASA is, at 6 p.m. Central Time today, August 25th, the National Hurricane Center noted that Harvey had strengthened to a Category 4 hurricane. So this is at its height, just before I think it's reaching landfall here. And once it does reach landfall, we have another video to share with you guys.
Got all the good videos.
All the good videos. I was glued to this all weekend. Okay. So now, there's no sound for this one. Quote, the Global Precipitation Measurement, GPM satellite, measured rainfall in Hurricane Harvey on August 25th at 7:50 a.m. Central Time and found that intense storms in the eastern side were dropping rain at a rate greater than 3.2 inches or 82 millimeters per hour. Tallest storms near the Texas and Louisiana borders reached an altitude of over 10.3 miles or 16.6 kilometers. On Saturday, August 26th, almost 10 inches of rain have already been reported at a few locations in southeastern Texas as of 4 a.m. Central Time. And that's the end of that quote there. But we know that that's not where it ends, right? So
yeah.
Now the hurricane has reached landfall. This is normally where it loses a lot of energy, right, Tom?
Yeah, because it gets all of its hurricanes get all their energy from the latent heat of evaporation, it's called, from the warm water that it's on. So that's usually what you see. It goes on land, and that's when it loses a lot of its steam.
So it drops from a Category 4 hurricane in terms of wind speed and classification back down to a tropical storm. But
yeah, but that's not really the story with this one, right? The most interesting kind of crazy part of this one was just how much rainfall was occurring in the area. So the wind speeds definitely did some damage, but the story here was the crazy amount of rainfall and the flooding that came to areas that you weren't expecting as much flooding, being slightly further away from the shore from that storm surge.
Mm-hmm.
But the rainfall numbers were just record-breaking, off-the-chart rain.
Yeah. So by Monday today, as Harvey stalled over southeastern Texas, rainfall accumulations had risen to over 30 inches in some areas. And we have an image from the National Weather Service to bring up here, just to put it a little bit into perspective, what we're talking about.
Yeah, there was actually a tweet by the National Weather Service saying that they needed to change their color scheme to accurately represent how much rain actually came to this area.
That's crazy.
As opposed to normally how they would match it.
Wow.
Just, they needed the brighter pinks and the purples and to represent just how much rain was in the area.
Yeah. Yeah, I mean, just really, really unbelievable. And now, Tom, right? The last video that I want to share with you guys is what's happening currently.
Current conditions.
Current conditions. I mean, as current as NASA's GOES satellite has provided imagery for us. So, Kyle, as soon as you're ready, we'll throw that last video up.
So even though it dropped down from the Category 4 hurricane pretty quickly over land, we can still see there's this massive system that's still bringing that crazy torrential rain to the area.
And I guess the scariest thing here, Tom, is that it's starting to make its way back over the Gulf of Mexico, where
it can get that energy again.
Correct. And
it's not dissipating, and it's still raining in those areas that have been flooded. And it's super slow moving. It's not really getting out of the area. And like you said, it's sort of wrapping back around over the water. So this is definitely a tough situation going on with this one.
Yeah. Rainfall accumulations are expected to increase by another 15 inches to 25 inches over the next few days. So if you compound that with the areas that have already been hit with 30 inches of rainfall, we're talking over
almost
4 feet of water.
Yeah, those are some staggering numbers.
That's incredible.
People are going to be flooded way off the coast and all kinds of different areas, and like we've seen on the news. It's a huge struggle for first responders to get to these areas because of how flooded it is.
Yeah,
it's crazy what's going on.
So, so now not only are areas of Texas being influenced by this, but the prediction, the forecast model is that the storm might move now a bit east,
to the southeast.
Yeah, towards Louisiana, where flooding can easily occur, as we've seen in the past.
Yeah, so this one's not even close to over. We still got to follow where it's going. There's still a ton of rain coming out of it, and we'll still have to track it and see what it's doing.
Yeah,
because it's already been such an issue for the people in Texas. If it's another issue somewhere else, I mean, there's only so many people that we can send to that area.
Yeah,
this storm is quite a challenge to meet all the demands that it's creating.
And the relief effort is going to take a long time, just in terms of once that water finally drains back into the Gulf of Mexico, what kind of damage can you anticipate with 4 feet of water that's been sitting there now for days? Right? Well, I guess 4 feet hasn't been sitting, but 2 feet of water has been sitting there for days.
Yeah, I've seen some crazy flooding pictures, like roads all the way up to the signs, like overhanging it with the lights just completely submerged in like many feet of water.
Yeah.
In such a large area. Crazy stuff.
Yeah. So, once again, our best goes out to those dealing with this currently in Texas. We're no stranger to coastal flooding and hurricane damage, Tom, because
being on Long Island.
Yeah, being on Long Island, we were just not just, but recently struck with the Hurricane Superstorm Sandy,
and then Irene.
And Irene before that, which caused quite a bit of damage over here.
But we didn't see anything like the rainfall that this one's bringing.
No,
this is something like whenever you read another quote, it's like, this is just not really a thing. This is almost an anomaly of how much rain there is.
Yeah.
So it's kind of frightening how quickly this thing developed and how much output is coming out of it. It's some scary stuff that it's like almost a different beast than it used to be. It's like, how did this happen?
Yeah.
Wild stuff.
It is very bizarre. I'm sure that, meteorologists and atmospheric scientists are going to look to this as a freak storm, but also one worth studying because
things may develop like this in the future.
Exactly.
As the water slightly warm even more, it'll only exacerbate growing a system faster and more.
Yeah. So we'll continue to kind of monitor this as it develops, and if there are any major changes or scientific things that come out of it, we'll of course try to bring light to it. How's our chat doing? I accidentally closed our chat. How we doing in there?
We are chilling as of now.
All right. Shall we move forward?
Sounds good. Yeah, the hurricane's crazy stuff, but must move on.
We must move on. Number 2, Tom. Heading over to the rumor mill a little bit here.
Once again.
Yeah. LIGO may have detected the first gravitational waves from a neutron star collision rather than a black hole merger.
So all of the other LIGO detections looking for gravitational waves have been from a black hole merging into another black hole.
So far,
those are all the ones we've observed.
That's what we think.
And this seems to be the first one that might point towards a different forming with being 2 neutron stars.
Yeah, so I thought our audience might appreciate just a little crash course on what a neutron star is, how it's different from a black hole. So I've got a video to bring up which should do just that.
Sounds good.
This video is courtesy of NASA Goddard. And Kyle, once you're ready to hit it, let's hit it.
When a star, bigger and more massive than the Sun, runs out of fuel at the end of its life, its core collapses while the outer layers are blown off in a supernova explosion. What's left behind depends on the star's original mass. A star roughly 10 to 20 times our Sun leaves behind a neutron star. A more massive star becomes a black hole. Unlike black holes, neutron stars are directly observable, usually as pulsars, the lighthouses of the cosmos. Discovered 50 years ago, they are the densest observable objects in the universe. Neutron stars compress up to twice the Sun's mass into a city-sized sphere. Matter is packed so tightly that a teaspoon of neutron star interior would weigh more than 1 billion tons on Earth. Still, the nature of the ultra-dense matter in the cores of neutron stars is unknown. Because neutron stars pack so much mass into such a tiny volume, they produce gravity strong enough to bend the light they emit, distorting their appearance in a way that enables the mass and size of the star to be measured. Scientists cannot reproduce the extreme conditions in and around neutron stars on Earth. They must look into the galaxy to answer decades-old questions about extreme matter and gravity. NASA's Neutron Star Interior Composition Explorer mission, or NISA, will make X-ray observations of neutron stars from its perch on the International Space Station. It will give astronomers more insight into these mysterious objects, helping determine what is under their surface. A multi-purpose mission, NISA includes a technology demonstration called Sextant. It will analyze NISA's observations to validate the use of rapidly rotating neutron stars as navigation beacons for travel in deep space throughout the solar system and beyond.
Cool.
Nice, huh?
So that's what a neutron star is.
So now...
And now they're saying a neutron star merging with another neutron star would have enough energy to send the ripples through space-time as gravitational waves.
Yep. So we can look at an animation of what that might have looked like. This is courtesy, again, of NASA Goddard. So as soon as Kyle gives me the go-ahead, just so that we can... We've talked about gravitational waves quite a bit on trèSci in the past, but just to catch everybody up to speed on what we're talking about again. Here's a short animation of what that would kind of look like. So we've got
these two super dense neutron stars.
Yep.
Coming close.
Doing the dance.
Orbiting around their common center of gravity, and then so when they finally do merge, they release a huge burst of energy.
Yeah.
And then that would send the ripples across space-time that we could measure.
Correct.
Okay.
Supposedly. Right?
That's the...
And the other thing there to point out is the flash, right, of light, basically. That is unique, supposedly, to neutron star collisions, whereas black hole mergers, no light really is emitted because all that light is not able to leave the surface of each black hole.
Yeah.
So LIGO is saying that well, LIGO is actually not saying anything, to be honest.
So this is all leaked.
This is all kind of
right?
Yeah.
Like none of it's been totally confirmed, so that's kind of why we're talking about it like this.
Yep. So I wrote here, as is the usual culprit with making embargoed information public, various reports from astronomers on Twitter suggest that some of the world's major telescopes have begun pointing to a specific location in the sky with hopes of glimpsing the electromagnetic radiation, aka light, that could be emitted from a neutron star collision event. Hubble Space Telescope Proposal 14804 and an audible of the Chandra X-ray Observatory's schedule of observations all but confirm that there is something exciting to look for. And we can show you some of that from these webpage sources that we can bring up. So the first one here is the Hubble Space Telescope proposal, right? Hubble Space Telescope, Tom, it's a very prestigious telescope to be able to use, because if you're using it, you know, every astronomer wants to use it. It's one of our most powerful telescopes.
Yes, you need a good enough reason to say this is why I want to use it.
Exactly. So this proposal comes by way of Andrew Levin from the University of Warwick. It's titled Rapid TOO. I believe that is a... what does that stand for again? A target of opportunity. Thank you.
Okay.
Got it. Rapid target of opportunity, right? So, like, they only have this short window of observing this thing. Observations of the first gravitational wave counterparts. And so, basically says it right there in the abstract. They want to be able to measure some sort of light coming from this and maybe associate it with heavy element production in our galaxy, Tom.
Yeah, so basically they're saying that this might be an option for how the heavier elements in our universe are formed as another method of being formed, as opposed to just being created in supernovas. It might be able to be just two mergers of neutron stars to create heavy elements also.
Yep. And
so that's the goal of...
That's the goal of that Hubble Space Telescope experiment that, you know, is not really announced yet or anything.
But that's what they're planning on, yeah.
And then the Chandra X-ray Observatory, if we bring up the next webpage here, we can read they posted on Friday that their current observing schedule is being replanned to incorporate an observation of SGRB 170817A, which is the designation for this part of the sky, which was accepted as a target of opportunity on August 18th. So they're basically saying, like, hey, all you guys that have things planned for observing with the Chandra X-ray Observatory, we're pushing you back a little bit because we're going to squeeze in this target of opportunity, this small window to take a look at this part of the sky, because we think something happened here.
So we want to take a look.
Nothing has been officially announced thus far, but according to the LIGO.org webpage news posting on August 25th, quote, a very exciting LIGO Virgo observing run is drawing to a close August 25th. The Virgo and LIGO scientific collaborations have been observing since November 30th, 2016 in the second Advanced Detector Observing Run. searching for gravitational wave signals with the first 2 LIGO detectors, then with both LIGO and Virgo instruments operating together since August 1st, 2017, which we covered on trèSci Weekly. Some promising gravitational wave candidates have been identified in data from both LIGO and Virgo during our preliminary analysis, and we have shared what we currently know with astronomical observing partners. Right? So they're like, hey, we're cluing in the right people for following up on this. We are working hard to assure that the candidates are valid gravitational wave events, and it will require time to establish the level of confidence needed to bring any results to the scientific community and the greater public.
So after all that stuff that we talked about,
hush hush.
Yeah. It's weird because this is what we talked about last time about gravitational waves, and it was initially started by information being leaked on Twitter about just people knowing that people need this time on the observing thing, like the Hubble. They know they need this time, so they look at who's getting it,
right?
And they're sort of just predicting what's going to happen.
Yeah, I mean,
it's just one of those things again.
I get, right, and we talked about on that episode why there are embargoes. Because there is a level of prestige to being the first to discover something, right? Your name gets etched into history. So I understand why there are embargoes for these types of information releases. But I mean, at this stage of the game, like, yeah, we know who's writing proposals for telescope time, so it's very easy to figure out, like,
what they're looking for.
Right.
And,
this person has been researching this for a long period of time.
And they're asking for this piece of technology to look at this.
Right. Means they probably have some level of confidence that they found it, So I think it's cool. And of course, as we learn more about it, we'll bring it up.
Yeah, hopefully we'll learn more about heavy element synthesis or more about neutron stars. We'll see what we can gain.
Yeah, really, really cool. Moving on. Numero 3.
Sounds good. What are we talking about now?
Keiichi Ohnaka et al., using the European Southern Observatory, or ESO's, Very Large Telescope Interferometer, or VLTI, have recently published a study titled Vigorous Atmospheric Motions in the Red Supergiant Supernova Progenitor Antares. Right. So
we're going to be talking about a red giant.
We're going to be talking about a red giant. Tom, what is a red giant?
So, a star like our own, they say it has to be between 0.3 the mass of our sun and up to 8 masses of our sun. As it goes through stellar evolution, as it goes burning what it's made up of, right? It starts burning all the hydrogen, and then once it burns up almost all of the hydrogen, it ends up burning like a shell of hydrogen.
Mm-hmm.
And as it starts burning up that last little bit of hydrogen, it starts swelling up to a greater size, right?
So the fusion has to change if the hydrogen is no longer available.
That was the initial fuel that it burned up.
Right, and then so it'll start taking the hydrogen that is converted now into helium, and it has to either ignite and burn helium, and to do so, your hydrostatic equilibrium changes, right? And so to balance that out, the star will swell to a much, much larger size.
It gets way bigger, but it also gets cooler on the surface, right? As it gets a lot bigger.
I believe so.
That's what makes it get red on the surface.
Yep. So this will be the ultimate fate of the sun.
Of our sun.
Eventually.
Yes.
Not for a long time, probably another 5 billion years or so. But we see lots of red giant stars out in our own galaxy, and so it's not uncommon for stars to go through this as they go through their evolutionary cycle.
So as they lose their hydrogen, they end up starting to burn differently, and that causes them to swell up a lot bigger, and then voila, you get your red giant.
Yep.
So you can keep burning and keep being a star, basically.
So this particular study, Tom, is talking about the red giant star Antares, which is in the night sky. You can see it.
So we're just studying the dynamics of this individual red giant star.
Yep. And so I thought we would read through the abstract of this paper and I'll bring up some graphics and some videos, and we'll see if we can sort of almost translate the science jargon into into more layman's terms. Right? So here we go. Quote, reading the abstracts. Red supergiants represent a late stage of the evolution of stars more massive than about 9 solar masses. So I'll bring up the first image, Kyle, if you don't mind. And this is kind of just going back to exactly what we said as an introduction to this, is that there are different life cycles to different size stars.
Yeah, so depending on how big you are when you get started, your eventual fate will be different than another star of a different mass.
Yeah, I know it's a little tough to see because our window, Tom and I are blocking it here, but the third kind of row up from the bottom is a sun-like star or the sun. Its fate is that it will eventually turn into a red giant and then a planetary nebula and then a white dwarf. We're talking about Antares, which is started out as a more massive star, I believe. And so, you know, even stars more massive than the sun, if they even started as a blue supergiant, they will eventually go through a red giant phase as well. So,
as they're burning that fuel, they'll still be a red giant.
Exactly. So, continuing on, and this image, by the way, credit goes to NASA JPL for this graphic. At this evolutionary stage, massive stars develop complex, multi-component atmospheres. Bright spots were detected in the atmospheres of red supergiants by interferometric imaging. So we'll bring up the next image, Kyle. Interferometric imaging is a technique where you can basically combine the viewing power of a series of telescopes, even if they're separated, right? So
by distance, yeah.
Right. We typically think of like one telescope having a certain field of view that you can look at, but there's actually a clever way to basically link up telescopes that are separated on the ground and combine their viewing power into one ultimate image, in a sense. So that's a very rough way of putting it. But anyway, this image here is of the Very Large Telescope Interferometer that ESO used for this particular study. So credit, of course, goes to ESO for this one. Above the photosphere, the molecular outer atmosphere extends up to about 2 stellar radii. Furthermore, the hot chromosphere, 5,000 to 8,000 degrees Kelvin, and cool gas, less than 3,500 Kelvin, are coexisting within around 3 stellar radii. So we're just talking a little bit about the layers of stars. So we'll bring up the next image. Right. And this is an image that we actually used on last week's episode. Yeah. Kyle and I talked about. So stars have different zones, different layers that we've identified.
How the energy gets transported and different zones of temperature and pressure.
Yep. So what they're saying here is that Antares' outer atmosphere extends outward from the photosphere, which would be kind of the last layer that we can see with our eyes. It extends a little bit further out than twice the radius of that star. And then its chromosphere, which we talked a little bit about on last week's episode too, chromosphere is the layer just beyond that, and there is that layer and some cooler gas kind of existing together out to about 3 times the radius of Antares.
Gotcha.
So that's a little odd, right? Because how are these different temperatures existing?
Doing what they're doing, yeah.
How is there no heat transfer here?
Yeah, so it doesn't seem to match up with what we thought we knew about red giants, right? Like, how is it? It doesn't match. The observations don't match what we thought we would see in a red giant.
Right. The dynamics of the complex atmosphere have been probed by ultraviolet and optical spectroscopy. However, the most direct, unambiguous approach is to measure the velocity at each position over the image of stars as in observations of the sun. right? And so we'll bring up the next image here. This is actually the data from Ohnaka et al. So credit goes to them for this. And what they're basically saying is, yeah, we can look at the light in the ultraviolet part of the spectrum and the visible part of the spectrum, and we can try to piece together how this complex atmosphere all works together. But the easiest way to do this is to look at the velocity of the motion
of the particles that are...
Basically, yeah. In order to do that, though, Tom, you have to have an extremely high resolution
to be able to measure the changes in velocity.
Right, because you actually have to make Antares, this pinprick point of light that's in the night sky, a disk, a circle, right? We have to be able to tell what is up here on the star versus what is down here on the face of the star versus what is over here, and that's hard to do. And it's actually something we've never done before with any other star other than the sun.
Yeah, so this is the first time we've been able to do this.
Yep. And so here is some of their data. If we're looking at it, we're able to see that it's not uniform, basically, across the whole face of the star, right? So there are spots that are moving faster than others, and we can tell this over a variety of different wavelengths. They check it in, This looks to be kind of a band of wavelengths in the ultraviolet. But yeah, so I thought that was very interesting. And then what they do with all this, Tom, is they're going to piece it all together and create one image that would represent what is going on the surface of Antares. So
this is our first picture of the actual dynamics of another star, like what it kind of looks like on the surface, where it might be hotter and cooler. This is kind of like the first time we've been able to piece together the information about another star, or
I think so, but I'm not prepared to make that claim about it.
I remember reading articles saying that it's basically the best look we've gotten at another star other than our own. Like actually being able to discern features, like you said, where it's hotter in some areas than others, sort of what's going on with the dynamics of it. I think that's the first time they've been able to sort of scratch it out for another star.
Yeah, it's definitely the first time we're doing it with a velocity field.
Okay.
And, as opposed to looking at maybe different
just the spectroscopy
heat signatures, and spectroscopy and light signatures. So continuing on with the abstract, here we report mapping of the velocity field over the surface and atmosphere of the prototypical red supergiant Antares. And we'll bring up the image now. So here's the collection of images, all kind of spliced together to give us the best picture of what Antares would look like if we were to just be able to look at it. And you can see, again, there is no uniformity to it. It's not like our sun, right? Where you can't, you can't really tell
one part from another.
Right.
When you look at it, it's just like if you looked at it during the eclipse with your glasses, it's all just a yellow circle, and you can't really tell one part being different from another part. It just all looks like the sun.
And I think what they're saying here, Tom, is that Antares would look significantly different in different areas of what...
Yeah, depending on where you're looking at it.
Right.
Yeah.
So I thought that was pretty cool. There's also a video that we can bring up of an artist's rendition of what that might look like. So I don't think there's any sound to it, but Kyle, if you wouldn't mind bringing up the video here.
But it seems to sort of make sense, right? If you're going into the red giant stage, you're getting a lot bigger, and you're changing up the physics and chemistry a lot. So I guess seeing, anomalies over here and differences over here, you could see it being a more dynamic and crazy atmosphere when it goes through so many changes throughout its cycle. So, definitely makes sense to me.
Yeah, for sure. Yeah, why would it be static? It's actually, now thinking about it, it's almost weird that the sun
is so uniform.
Yeah, is uniform and static. But both of those, the image and the video, are courtesy of ESO again. I really like that imagery of the artist rendition of it, because I think that's really cool.
Yeah, so I guess the difference between the red giant and a star like our own is that our star is happily burning its insides right now. So I guess that's why you could say it kind of makes sense that it is so uniform, that it's just burning its energy, it's just doing its thing. Whereas the red giant is going through a lot of changes with what it's burning and where it's getting its energy from, and it's a more dynamic system than just a happily burning star like our own, until it eventually needs to use a different fuel source for its energy, and then it will eventually get maybe a little more chaotic and different.
Yeah, absolutely. So continuing on with the abstract here, the two-dimensional velocity field map obtained from our near-infrared spectro-interferometric imaging reveals vigorous upwelling and downdrafting motions of several huge gas clumps at velocities ranging from about -20 to +20 kilometers per second in the atmosphere, extending out to approximately 1.7 stellar radii. Convection alone cannot explain the observed turbulent motions and atmospheric extension, suggesting the operation of a yet-to-be-identified process in the extended atmosphere. And that, I think, was the most profound piece of this abstract, of this study here, is that they're seeing all this turbulence. They're seeing that this doesn't,
that this is moving in this direction, that's moving in this direction.
And convection,
just
by
the physics
itself,
of convection wouldn't describe that.
Right.
Is what they're saying.
And so we'll bring up one more image here of what we're talking about convection. So convection, we have convection here on the Earth even, where our plate tectonics undergo convective cycles in the mantle, right? So heavier things will eventually sink down and lighter material will eventually kind of rise up.
Yeah, and as it gets hotter, it'll make it less dense and help it rise.
Yep.
And you even get convection currents, like if you're cooking in a pot, as it starts boiling, you'll get the flow cycle of a convection current based on uneven heating.
Yep. So it's just like a physical mode of moving,
energy transport, right?
And moving things around. And so we have convection in our sun. We know that there's a region of the sun that most of the heat transfer that is happening, right, as heat moves from the core to the surface, undergoes that transfer via convection, and we can see this in red giants as well. But what we're saying here, Tom, is that convection can't explain
these large upwelling and downwellings that we're seeing.
Exactly. And so now a whole new
way of understanding the physics in the outer atmosphere of a red giant is saying, like, oh, we need a different way to explain this.
Right. And since this technique works so well to be able to describe the velocity map and basically what we're seeing on Antares, it can potentially be used for other red giant stars that we know of.
We can compare them
and see, if we can get a better idea of what the physical process that is leading to this is. This is important to know, right? Because our sun is going to do it eventually.
It is.
So, just an interesting study there. The last image credit goes to ESO again for the convection piece there. And, I thought that was cool. So, looking forward to, seeing more stars resolved to that disc size shape there.
Pretty cool.
Moving on, number 4. A couple quick ones now, Tom. Elon Musk has revealed the first official image of SpaceX's spacesuit design via Instagram. So we can bring that image up.
It looks like the future in the picture.
It kind of does. Where did my pictures go? Hang on a second.
I saw a really funny tweet about Elon Musk saying, what if he's just from the future, slowly giving the ideas of future technology and making these companies, and he's from the future.
He could.
I mean,
I wouldn't put it past the man.
The Earth's flat, so I mean, you never know.
So he wrote on Instagram, quote, "First picture of SpaceX spacesuit, more in days to follow. Worth noting that this actually works, not a mock-up. Already tested to double vacuum pressure. Was incredibly hard to balance aesthetics and function. Easy to do either separately." End quote. Tom, what do you think of the design here?
It looks pretty cool. I think it's way sleeker. It looks like it's easier to move around in.
Yeah.
If you were to actually go on like a walk around the space station or to do something, Seems more practical, like you'd be able to do more things with.
Yeah, I agree. I think it's sleek but clean.
It's nice.
It's nice. It's not.
If you were a space avatar, you might be happy with that one.
Yeah.
Like, I'll be cool. I'll be that guy.
Yeah, I'm glad it's not like just over the top. You know, like we've gotten so many sci-fi films and video games,
speculating,
of like what this might look like, and you know, I don't think it needs to be more than this. I think that this does a nice job.
Pretty cool.
Pretty cool. And number 5, Tom, PBS has released a trailer for its upcoming documentary, Death Dive to Saturn, as part of its NOVA TV series. We can watch the trailer for that together.
Yeah, so we've been talking about the Death Dive to Saturn. Whenever we talked about Cassini, the spacecraft, that's the one that they're talking about. It's been making all those loops in between the rings.
Yep.
And now this is its final frontier before it ends its journey.
Yeah. So as soon as we get the go-ahead, we'll play this video together.
Cassini, our eye on Saturn, reveals amazing new worlds.
It's astonishing, just absolutely glorious.
But now, a fiery end approaches.
It's on a path towards death.
Follow Cassini's incredible last moments.
Revealing Saturn from the inside out.
With up-to-the-minute coverage.
This is an adventure.
Death Dive to Saturn on NOVA.
So now, when can we watch this?
Set to air on September 13th. The feature will be a prelude to Cassini's grand finale when we say goodbye as it plummets towards Saturn's interior on September 15th, 2017. So 2 days before the actual grand finale.
And we talked on a previous episode, why are they destroying it? We talked about it. They're basically saying, we don't want this spacecraft to influence any life that might be out there on the moons of Saturn. So instead of just letting it go somewhere else or anything, they're just driving it right into Saturn and destroying it instead of letting it impact any potential life.
Yeah.
Which is kind of a crazy thing that they're doing, but
yeah,
pretty cool.
No, absolutely. Makes sense.
Yeah. It's like just a way to sterilely get rid of this spacecraft.
Yeah.
You just got to shoot it into Saturn.
Yeah.
Get rid of it.
And I do want to note, tomorrow, NASA is going to be holding a media teleconference about Cassini's science operations for the final few grand finale orbits that it's doing.
Like, what kind of science they're looking to do?
I think so. Probably, yeah. I mean, this is the first time.
Recap, and now they're in between Saturn and the inner part of the rings.
Right.
So getting close to the surface.
Yeah, that's like the first time we've been in this region of space before, so I'm sure this up close look at Saturn
and the rings
from this perspective, probably some interesting results that I hope that they'll unveil tomorrow.
So we had a ton of space news. Just real quick, at the end, we wanted to go over some space story that has been shared with us a few times.
Yep, so we're calling this segment fakenews.com. Here we go.
Come here for your fake news.
Yep. So, Tom.
Yeah, so the story that got shared on Facebook for me multiple times, it was that NASA confirmed 15 days of darkness in November for some crazy reason. When you read the explanation about interaction between Venus and Jupiter and the sun getting hotter and just these crazy claims of things happening, and just none of it is true. It's literally all nonsense.
This is what Donald Trump has been warning us about, right?
You gotta watch out for that fake news.
It's fake news.
But it really is, though. Yeah.
It is. No, it is. It's all malarkey. I saw it as well. A bunch of people posting it, sharing it, commenting on it, and I just was like, oh boy, here we go.
Yeah, and it's actually kind of funny when you read through it, because it's...
Should we read an excerpt?
Yeah, you can read part of it.
So this is all false, ladies and gentlemen. This is not actually happening, but we thought it was funny. So... reflectionofmind.org writes, NASA reports that this strange occurrence... Oh, I should jump back up a little bit. NASA confirms what's been circling the web recently. Our planet Earth will experience total darkness for 15 days in November 2017, starting from November 15th to November 29th, a day before my birthday there, Tom. Not really. NASA reports that this strange occurrence was expected to happen, but they didn't know exactly when. Upon more detailed examination, the astronomers from NASA confirmed that the phenomenon will start on November 15th at 3 o'clock a.m. and will most likely last until November 30th, 4:45 p.m. According to experts, this blackout will be caused by an astronomical event between Jupiter and Venus.
So Jupiter and Venus nowhere near each other, right?
No.
Okay, so what's going to happen?
There was even a detailed 1,000 pages document written by Charles Bolden, head of NASA, explaining the strange event to officials at the White House. According to the report, during this specific period, Jupiter and Venus will come in close proximity of each other and will be separated by just 1 degree.
So they're not getting any closer to each other.
Yeah.
I don't even know what being separated by 1 degree means.
Like,
that's not
in
happening.
the sky? That doesn't mean that they're physically close together. Yeah. Venus will move to the southwest of Jupiter, and as a result, it will shine 10 times brighter than Jupiter. Not true. Venus's bright light will heat up the gases in Jupiter, causing a reaction which will release an absurdly high amount of hydrogen into the space. This reaction will come in contact with our sun at 2:50 a.m. on November 15th. Once the hydrogen reaches the sun, a massive explosion is bound to occur on the surface of the sun, increasing the temperature to more than 9,000 degrees. It's over 9,000 pounds.
Over 9,000 degrees.
The whole process will generate so much heat that the sun will change its color into a bluish shade. Once this happens, the sun will need a minimum of 14 days to restore its normal color and temperature.
So here's what I think happened. There's an undergraduate student doing an assignment he really hates. And he's like jacked up on energy drinks. And he's like, you know what? I'm done with this. I hate this. I'm just spewing some nonsense out there. And somehow people found it and wanted to believe that it was going to get dark and that NASA said it would happen, but this is all shenanigans.
It could be. So
it's funny though how this one just sort of made the rounds again over the last few weeks.
Yeah,
this story
almost never fails, man. The malarkey never fails. So reflectionofmind.org attributes globalrevolutionnetwork.com as their source for this news. Either way, both of you guys, you're fake news.
And you should follow actual NASA on Twitter and Facebook, and you could just see what they're telling you.
Yeah.
You don't have to read a bogus article about NASA. You can just follow NASA.
Yeah. Or just follow trèSci.
And we'll tell you what NASA says.
We'll tell you what NASA says. Tom, it's been my absolute pleasure to do this show with you this week.
Another good one.
Another good one. Dirty 30 in the books. We will be back next week with more science news. Episode 31.
So keep tagging us. We'll probably still follow the hurricane a little more.
Yep.
Maybe give some final rainfall totals and maybe a little more analysis of exactly how it got so extreme. But
definitely
keep following that.
Definitely. And yeah, we will see you guys next week.
Yeah, thanks for watching.